Okay, so in Algebra 1, Chapter 4, we're looking at linear equations. And what we're going to talk about now is something called slope. And slope of a line is the description of the steepness. Now, we've talked about steepness before, so we're just talking about it again, and we're going a little bit more in depth with our steepness. Slope is a ratio, also known as a fraction, that compares the amount of change in our dependent variable y to the amount of change in our independent variable x. When we're using tables, we compare the change in y values to the change in x values, and that gives us this formula. We did that a lot in Chapter 3, so we're still doing it again in Chapter 4. How do the y values change over how do the x values change? And that tells us our steepness or slope. When we're using graphs, we compare the change in the y values to the change in the x values. So when we're looking at a graph, this is our y-axis, which goes up and down. So the change in y values tell me my rise. If I'm going up, I'm going to have a positive value. If I'm going down, I'm going to have a negative value. And then my run is my x values. And as you look, our x-axis goes across. So our cross tells us our run or our side to side. Now, if we're going to the direction to the right, it's going to be a positive value, kind of like as my x-axis moves to the right, it's positive numbers. And as I move to the left, it's negative values. And so we're going to use that to help us find our slope. Now, one of the rules that we use is just by looking at it, you can kind of get an idea if it's positive slope, negative slope, or what. So when our line goes like this is going to be positive slope. And how that looks is I go up, which is a positive value, and then to the right. So positive over positive gives us a positive slope. Now, I can also look at it as going down, which is negative, and to the left, which is negative. And negative over negative cancels each other out and still becomes positive. And so as my original line here goes up to the right, that's telling me that it's positive because of these different changes that we have. Now, on a negative slope, when I look at it from here, I go down, which is negative, and then I go to the right, which is positive. And negative over positive gives me negative. I could also look at it the opposite direction. I go up, which is positive, and I go left, which is negative. And that still, as a fraction, gives me that idea of having a negative slope. Now, zero slope looks flat. And so when we deal with these flat lines, we've got a zero slope and an undefined slope. Zero slope is flat. So if I have this little dude walking here, he's walking flat, no effort, no big deal, zero slope. And if you think about this line, there is no up, there is no down. And that's how we're getting the zero on top. There is no up and down to it. There is only a cross. And so 0 over anything just becomes 0, and that's how we get that zero slope. Now, our undefined slope is one of those that you really couldn't walk on it. So zero slope, you can walk flat, no big deal. It's not like you're walking uphill over here, or you're walking downhill over here. On undefined slope, you can't walk on this at all. You're falling into nothingness. So you really can't walk on it without special rock climbing equipment. So because of this, this is undefined. How is it undefined again? So let's look at it numerically. Whoa, what just happened? Okay, I don't know what just happened, but here we go. So we're going to look at this numerically. On the undefined slope, we've got our little dude. And numerically, we're moving up or down. But we're not going across. No across. Which means that there's no movement, and that gives us 0 on the bottom. Now, dividing by 0 is the one mathematical operation we cannot perform. And that's how we get an undefined value, because there's no value there at all. And we can say undefined is really a 0 with a line through it. Be careful though. 0 is 0 and it's an actual number. A 0 with a line through it is undefined because there is no value for it. Okay. So now what we're going to do is we're going to take a look at these graphs and we're going to calculate the slope of the line or the steepness of my line. And so what I'm looking for with this is a rise over run. So I have 2 points on my line and it's up to me which point I start with. I tend to always start with the point on the left-hand side, but you can start with the point on the right. If I start with the point on the left, to move to this point, I have to go rise, and I would count how far I'm rising. So 1, 2, 3, 4 spaces. And because it's up, it's positive. And then I calculate my run. So my across, 1, 2, 3, 4, 5. So my slope is 4 over 5. And so numerically, I can compare that to other slopes to figure out which one's steeper. So here, I've got my 2 points. And again, it doesn't matter which one I start with as long as I do a rise over run. So I'm going to go ahead and show you this other way. I'm going to start down here at this point, and I would rise 1, 2, 3, 4, 5, 6. So I'm going up 6, and I'm going left 1, 2, 3. So I do rise over run, and 6 over negative 3 is negative 2. Now let's go ahead and look at it another way. I could go from this point, I could go down 6, and then I could go to the right 2. So that would give me negative 6 over 2. No, that's not 2, that's 3. Sorry about that. Which gives me negative 2. So it didn't matter which direction I went, I ended up with the same slope anyway. Now it is your responsibility to always reduce your slope. So even though I had the 6 over negative 3, I needed to reduce it for our final answer. Okay, so let's look at our next one. 2 points. I'm going to rise 1, 2, 3. I'm going to run 1, 2, 3, 4. So my slope is 3/4. Okay, let's look at our next one. I've got my 2 points. I'm going to go down 1. And then I'm going to go over 1, 2, 3, 4. And that's my slope. So from here, here's my 2 points. I go up none. And I go over 1, 2, 3, 4. 0 over 4 is really just 0, and that's my slope. You could also tell that just by looking at it. Okay, our last one. Here's our 2 points. I'm going to go ahead and start up here. I'm going to calculate my rise. Down 1, 2, 3, 4, 5, 6. So down 6. And I went over none. 0 is on the bottom, so it is an undefined slope. And that's how we use our graphs. Okay, going back to chapter 3, how do we use our tables to calculate our slope? So let's look at how my y's change. Each time I'm going down 1. Then we look at how my x's change every time I'm going up 3. And then it's how my y's change over how my x's change. So it's negative 1 over 3. For our next one, we do the same thing. I'm looking at how my y's change. I'm going down 3. And then I look at how my x's change. I'm going up 2. And that's my slope. That's it. Okay, we can also calculate the slope of a line through any 2 points by using algebra. And so here's our formula. Our formula is based on the idea that each point has an x value and a y value. So x1, y1 means the x value of my first point, the y value of my first point. x2, y2 means the x value of my second point and the y value of my second point. And so what do? Is I plug it into this formula. where I do y2 minus y1 on the top. That allows me to calculate the change in y's, over x2 minus x1 on the bottom, which allows me to calculate the change in x's. So I'm going to go ahead and look at my 2 points. This is my x1, y1, x2, y2, because this is my first point and this is my second point. So this one has 1s, this one has 2s. And then I plug it in. So I'm going to do y2 minus y1 over x2 minus x1. And so now that I've written it out, I can go through and change things. So that way I just purely write out the formula. So here my negative turns to plus. So 4 plus 3 gives me 7. And then here, -1 minus 2, I'm going to go ahead and add a line and change the sign. So -1 and -2 becomes -3. And that's our slope. Now, a lot of times, instead of labeling x's and y's, I will instead just circle my y's, because I know my y's have to go on top. So I'm going to do y2 minus y1, and then my x's are uncircled. So x2 minus x1. So 1 minus 5 gives me -4. 8 minus 2 gives me 6. And if I can reduce my fraction, I must reduce the fraction. Both of these can be divided by 2. So -4 divided by 2 gives me -2. 6 divided by 2 gives me 3. And that's our slope. So in the next one, I'm going to do the same idea. I'm going to circle my y's. I'm going to do y2 minus y1 over x2 minus x1. So I've got some double negatives, so I'm going to go ahead and change my color so I see my original formula. I change my signs, add a line, change the sign. So now I have -3 plus 3, which is 0, and 7 plus 2, which is 9. So now I have to think about, is this 0 or is this undefined? And since 0 is on top, my answer is 0. Okay, so now I'm going to move to the next one. I'm going to circle my y's. So -4 minus -7, y's on top. And then I do x's, 6 minus 5. Now I'm going to go back and I'm going to go ahead and add a line, change the sign. So -4 plus 7, or I could think of it backwards. 7 minus 4 gives me 3. And 6 minus 5 gives me 1. If I can simplify it, I should. 3 over 1 is the same thing as 3. Okay, last one here. Circle my y's. 5 minus -3 over -1 minus -1. Got some double negatives, so I'm going to add a line, change the sign. 5 plus 3 gives me 8. -1 plus 1 gives me 0. And now I have to think, 0 or undefined. 0 is on the bottom, so this is undefined. And that's our slope.